Hello, everyone. Good morning. Guy Jacobson worked on the Acumos project. I'm going to sort of be the second half of Paul's talk for the most part, showing how you would deploy a model locally and just go a little bit about publishing a few more things that maybe you might have missed or just enrich a little what was said this morning. Let me make this full screen. All right. So publishing models, this is a way to share it with a wider group. There's a thing you can do to share models among your team members, like a specific model, and they become joint co-owners. You can publish to the company. When you publish it to a company, then your instance can look at the model, but it doesn't get distributed beyond that. There's publishing to public, which is what we saw Farheen demonstrate. When you do that, it enables the models to be federated to instances that are peered. So that's the way that models can sort of bubble up to other instances of Acumos. And publishing, as we saw, requires some kind of checking. It's sort of instance configurable. So this checking may be based on an editor or a publisher looking at it and giving it the green light, or it may be, in some instances, based on sort of automatic code scanning. I'm going to demo this. Maybe I'll skip this in the interest of time, actually, because we saw this already. So what I really want to talk about is to finish what Paul was started, which was onboarding. When you onboard a model, you bring it into Acumos, and we have support for right now three languages, and within those languages, most of the common toolkits that people would want to use, or many of them. We support Python, we support R, and we support Java, and this is based on what people have been, interested in building models in. One thing you'll see is we have two sub-varieties of onboarding once you build a model. Paul mentioned it briefly. You can push the model from within the command line or within the language. Command line isn't the best term for it. You can build into your script a command to push the model directly into Acumos, and you just need to have the URLs and the credentials sort of embedded in your script. Or you can dump it to a file and then take that file object and load it directly into Acumos. One of the things that we build that's the sort of the payload, the thing that people will want, is the microservice. We take that onboarded model and we create runnable microservices, which generally are Docker images that you can run anywhere. You can run Docker. You can deploy them to the cloud. You can run them to a local instance of Docker. And sort of going forward, we already have this a bit. You'll be able to build Docker images for different platforms and different type of deployment environments. So for example, if you have an ARM device, you'll be able to build a Docker image for ARM. Or if you have a specialized computing environment like ONAP or DCAE, we already have something to create deployable images that are for that specific platform and not just for a generic platform. Also, for example, if you have a specific hardware requirement, like you have a fancy NVIDIA GPU that you want to design for, that's another sort of target environment you can build for. All right, here's just a quick view of what the architecture of the system. Paul mentioned this briefly, but I'll go over it again. You download a client library, which is a small piece of code in the language specific that you're trying to use. And that helps you package up a model and get it ready for onboarding. So the three things it builds, Paul called them, I don't remember what he called them, but there's metadata, which describes the model, gives it a name, and it tells you what versions of software it needs. So for example, that's one of the things that the introspection builds. It looks in the model and says, oh, they're using TensorFlow VXXX. We're gonna need TensorFlow VXXX. And it goes through and creates those dependencies pretty much automatically. Protobuf is Google's protocol buffers language that we use. This is something that we use both as a description of the data types that we consume and produce and the services we offer. And we also use it to compile to create interface that's particularly efficient in packaging up data and serializing and deserializing. And then there's the model itself, which is all of the frozen serialized data structures that the training has provided, plus pieces of code that are necessary to execute the model. And all of this gets onboarded. And as a separate piece, there's this microservice generation that goes on. Right now, microservice generation is sort of automatically kicked off from within onboarding, But in the future, you'll be able to build other kinds of microservices from the same model. So if you want a specific microservice for a different architecture or a different deployment environment, that's possible too. We saw a demo of deployment to cloud, where you essentially have a model and you have credentials and a space on the cloud and you can deploy. We saw that was what Manoop had showed us. I'm going to show you how to deploy locally. And for that, you need basically one thing. You need to have a Docker host that you can run things on that is the right architecture. This is just x86 stuff. And to exercise it, you're going to need protobuf if you're going to use protobuf as your interchange format. So you'd have to sort of download it and have the protobuf installed. So this is the demo I'm about to go through. I'm going to tell you what the steps are, and then I'm going to stop showing you slides and go through the demo. So we saw the dumped model. We saw Paul dump a model onto the disk, right? And so he did that. I'm going to show you how you find that model how you're going to take that model and web onboard it. Then I'm going to show you how you find it inside Oculus. That's the in the portal. And then I'm going to show you how you would download the things you need, which are the Docker image and the protobuf. You would compile the protobuf into a class that understands how to serialize and deserialize the inputs and outputs for that class. And then I'll actually load and run the Docker image to create the microservice, show you a little test script that tests it out, feeds it data, and comes back, and that'll be the end of the demo. Now, let's go look at, this is the same model that you saw Paul using before. It's exactly the same. He downloads it, he dumps it locally, and I've already done that. I've downloaded it locally. I've dumped it locally. It's over here. There are 3 files, and I put them together in one archive. What I would do now is I run this program. He's run it too, so it's the same. I'm going to go to I'm going to log in as myself on Oculus the portal to see what I have. I have a few models. I'm going to go to web onboarding, which is here. Go here. This is onboarding by command line. I want to onboard by web. So I would just take my model. I would basically go to here and just drag and drop this into here. I'm not going to actually do this because it takes some time to build the microservice, but this is what I would do. And so I've already done this. So I'm going to show you what the result is. It ends up being a microservice. These lights will sort of light up as it goes through the steps. And once it's all done, you'll see it here. So here it is. It would look like this. I can download things. I can look at it. So one thing you can see is the signature. The signature is the protobuf that we saw. It has one service, classify image. That was the name Paul gave it. It takes bytes as input, and it returns a prediction, which is a label and a probability. Very simple. It's a string and a double. I didn't download any documents with it because if I were really publishing this, I would add documents here, like a paper of describing it. I could add a description to it. I could enrich it in all sorts of ways so other people could find it. But I'm just showing you how you put it on and onboard. A real user would have to find it somehow. So there would be more stuff here. And then here are all the model artifacts that come with it. Various things here. The 2 that are of interest to us are specifically the model itself, which is this big guy over here. This is a fairly large thing because it's a complete Docker image. And we're going to be deploying it locally, so I would download it. And the protobuf, which is really just needed for, that's exactly what you see under signatures. That's really just needed to compile so I can talk to the service. So put this aside for now. And so now I'm going to look at a terminal window. So let's say I've downloaded them already. I've downloaded the protobuf, and I've downloaded the image classifier. I would then load the Docker image into my Docker, and you can see that it's there. And it's this first one here. So I'm going to just start it up. All right. So what I've done here is I've basically mapped one of the ports to so it will be externally visible. This is the port I'm going to use to actually call the service on. And I start it up. Should start up. There it goes. using TensorFlow backend, doing some stuff. You can see it's doing something. And now I'll show you the code that I'm going to use to actually exercise it. This is something Paul didn't show you, but it's a little test program that I wrote. So what I have here is the first line is I've compiled the protobuf and I'm importing it because it gives me the classes that I need to serialize and deserialize the data, talk to the service. I've given the name of where the URL is that's running locally for the RPC to go on. I've written a little function to encapsulate the RPC. What it does is very simple. It instantiates the input class and puts the image bytes into it. It uses request and post to post the request to the locally running service in the Docker. It takes the output and deserializes it, and it returns a tuple that's the image label and the probability, just like we saw earlier. So then I just open the file, and I'm going to call this function. And when I call the function, I'm going to show you the result. So let's see that it runs. And I think the first time it actually has to download something. So there it goes. It came up with a prediction. And you can see that it did predict it was a scuba diver. So that was, just a sort of end-to-end description of how you would go about taking the model that Paul dumped, putting it in Occamose, finding it in Occamose. If I weren't using it myself, I would have added a lot of extra description and published it. Then someone else, which was also me in this case, downloaded the model, wrote a little interface code to talk to it, called it, and showed the result of what it did. And that's basically the very simple example of how you exercise Occamose by downloading and deploying and running a model locally. I have time for a question or two. All right, so I think your question is how you integrate, how you do multiple models together. And well, I think that's a perfect segue because lurking behind me is Kazi, who's going to talk about the Design Studio. The Design Studio is a tool that you can use to take multiple models, and not just models, but also tools that do data transformation and splitting and joining of data, and sort of wire them up into a composite solution to do something a little bit more complex. So that's, you wait till you see what Kazi says, and if he doesn't answer it, you can ask him the question.
I have a question about the latency when you hit the server with asking for a model that is not in memory. Because that sort of takes the time with local time to deserialize, especially transfer. So you do have a tool.
Well, we haven't really done a lot of measurements of performance yet, and so we chose TensorFlow for two reasons. One of which is that it's supposed to be high performance and good efficiency. So, wait, what? All right, well, we'll see about that, right? And the other thing is that the later versions of the tool can also use JSON if that works for you. So you don't have to use protobuf. That's the language we use to describe the services and the sort of default mode of communicating. But you can also use JSON. All right. Thanks, everyone.